Hello students, now we are going to discuss about quantum mechanical model of an atom. In previous class we discussed about the structure of atom. In structure of atom we discussed about the what is the mean by atom and what are the subatomic particles which are present in an atom, okay, and different models of different scientists which gave in different methods which are already we discussed. In now we are going to discuss about quantum mechanical model of an atom. Quantum mechanical model of an atom. Here the last atomic the model Bohr's model of hydrogen atom. In the Bohr's model of hydrogen atom we learn that here electrons are revolving around the nucleus in a circular paths which are called orbits. But later the scientist was he break that continuous tradition and said that here electrons are does not revolve in a circular path around the nucleus. Okay. Here according to Bohr's model of hydrogen atom, the nucleus is present at the every atom center of the atom. Here around the nucleus the circular paths are present. Here these circular paths electrons are revolving around the nucleus. That statement given by the Bohr's model, okay, Bohr's Niels Bohr. But next scientist Erwin Schrdinger here when light strike on a particle, it will disturb in the motion or velocity of an object and its position. Here according to imagine a dust particle is present in my hand, okay, when air is come in this direction the dust particles will be change its position, it will be move far away from us. Here also electrons are when revolving around the nucleus, it will be when we strike a light on the particles, it will be change its position and velocity. So based on this concept, Erwin Schrödinger said that electrons are not revolving around the nucleus in a circular path, which are electrons are present around the nucleus where the empty space is present. The electrons where are present around the nucleus, okay, outside of the nucleus, this place is called orbital. He said that where the electrons are finding the electrons where the maximum is called orbital, okay. According to Erwin Schrödinger, the probability of finding electrons maximum around the nucleus is called orbital, okay. Here based on this concept he said he overcome the where the electrons are present around the nucleus, okay. Here Erwin Schrödinger said that here based on this Erwin Schrödinger concept the different quantum numbers was proposed. In that quantum numbers there are more 4 quantum numbers are very important. In that first one, before that the Heisenberg uncertainty principle is important here. What says that Heisenberg uncertainty principle means it states that it determines that it is impossible to determine exact position and momentum of a moving particle. Once again, Heisenberg uncertainty principle. Dear students, listen carefully. What is mean by Heisenberg uncertainty principle? Heisenberg uncertainty principle means here it states that it is impossible to determine exact position and momentum of a moving particle. Here this statement was given by Heisenberg. This principle is called Heisenberg uncertainty principle, okay. Here next the quantum numbers. Here quantum numbers are 4 quantum numbers. Quantum numbers means which give the information about electrons where it is located around the nucleus is called quantum numbers, which gives the information or address of electron which is located around the nucleus of an atom is called quantum numbers. These quantum numbers are classified into 4 types. In that, first one, principal quantum number. Principal quantum number. Principal quantum number. Principal quantum number was proposed by Niels Bohr. Niels Bohr. It is denoted with small n. It is denoted with small n. Here n values increase. N value increase. N value increase. N values increase. Number of n values increase, number of shells increase, number of shells increase around the atom, around the nucleus. Okay, here n is equal to, we will take 1, 2, 3, 4. N is equal to, we will take 1, 2, 3, 4 or K, L, M, N. That means here, for example, take an atom. This is an atom. Every atom has nucleus at the center. Okay, here it has cells around it. For example, this is the first cell, second cell, and third shell, and fourth shell. Okay, these shells are indicated with by using 1, 2, 3, 4 or K, L, M, N shells. Okay, here which gives the principal quantum number, gives the information about main shells which are present around the nucleus. Okay, this is the principal quantum number. Azimuthal quantum number. Okay, dear students, listen carefully. Here what is mean by quantum numbers? Quantum numbers are gives the orientation or address of an electron. Here for quantum numbers are classified into 4 types. First one, principal quantum number. Who proposed it? Niels Bohr. Who proposed it? Niels Bohr. It is denoted with a small n. Here n values we can take as 1, 2, 3, 4. Okay, 1, 2, 3, 4 like that, which gives the information about how many shells are present around the nucleus in an atom. Okay, here next principal quantum number is azimuthal quantum number or angular. Azimuthal quantum number or angular momentum quantum number. Quantum number. Okay, it is denoted with small l. It is denoted with a small l. L values will be taken as from 0, 1, 2, 3, 4 like this. Here n values we will take 1, 2, 3, 4, but L values will be taken as from 0 onwards. Okay, 0 onwards. Here it will gives the information of subshells. It will give the information of subshells. Here before that, principal quantum number gives the information about main shell, where the electron is present in main shell, in which main shell. But this azimuthal quantum number or angular momentum quantum number gives the information in which subshell. In which subshell the electron is present in an atom. The L values will be taken as 0, 1, 2, 3, 4. Okay, like that. Next, third quantum number, that is magnetic quantum number. Next, third quantum number, that is magnetic quantum number. This magnetic quantum number was denoted with small m and subscript to small l value. It was proposed by Landé. It was proposed by Lande. The scientist name was Lande, which gives the information where the electrons are present in an atom. Here in this magnetic quantum number, we can use 2L plus 1 formula. By using this formula, we can find out how many orbitals are present in an atom. For example, take here n is equal to 1, 2, 3, 4. These are the main shells values. Here L is equal to, we will start from 0, 1, 2, 3. Okay. Here next to ML plus ML magnetic quantum number values, how we can find out means by using the 2L plus 1 formula. Here take, you will substitute the L values in this place, in this formula. 2 into L plus, in L place you can substitute 0, that means 0 plus 1, that means 2 into 0, 0 plus 1, how much the value? 1, that means first shell, okay, K shell or first shell has only one subshell, that is called S subshell or S orbital. It is also called S orbital. Here second one, substitute the L value. What is the after 0? L value is 1. Here keep 1. By substituting 1 in the place of L, you will get 2 into 1, 2 plus 1 is equal to 3. That means here you will get value 3. Here it will second orbital. Okay, second shell, it has 3 orbitals. Okay, it has 3 orbital, that is p orbital. Second one is p orbital. In p it has 3 subshells or orbitals. Next, substitute 2. L is equal to 2 plus 1 gives rise to 2 to the 4 plus 1 5. That means it has d orbital. In d orbital, how many, in d subshell, how many orbitals are present? 5 orbitals are present. Next, in the place of L, you can substitute next to 3 plus 1 gives rise to 2 3 is 6 plus 1 7, that means F orbital. Here S will gives the maximum accommodation to only 2 electrons. Okay, it has only one orbital. S subshell has only one orbital. It is also itself called S orbital also. Here p orbital. Okay, p orbital has p subshell. Okay, K L. After L, p orbital has 3 subshells. Okay, 3 subshells. That means it has give the accommodation 6 electrons. It will give accommodation to the 6 electrons. That means every orbital will maximum give the 2 electrons, maximum give the accommodation to only 2 electrons. Here S orbital has only one orbital. S subshell has only one orbital. So that's why it will give maximum 2 electrons accommodation. Here p orbital has 3, it will give 6 electrons, and next d, it has 5 orbitals, it will give 10 electrons accommodation. Next F has 7 orbitals, it will give 14 electrons accommodation in an atom. Okay, these are the magnetic quantum number. Once again, third quantum number is magnetic quantum number. It is denoted with ML. It was proposed by Lande. It was proposed by Lande. We can find out by using 2L plus 1 formula of magnetic quantum numbers in an atom. Here 2L plus 1 means, here when we substitute the L values instead of L, that is 0, 1, 2, 3, 4. That means when we substitute, we will get 1, 3, 5, 7. That means 1 means S in, for example, take here this is an, this is an atom, this is a nucleus, it has circular paths around it like this. Okay, here first shell has only one, this is n is equal to we will taken as 2, n is equal to we taken as 3, 4. Okay. Here first shell has only one subshell, that is S. Okay, main shell or K shell, it is also denoted with KLMN. Here first shell has only one subshell, it is denoted with S. Second shell, it has S subshell and P subshell. Okay, S subshell and P subshell. Next third shell, it has S, P, D subshell. Okay, 3 subshells, and fourth shell has 4 subshells, that is S, P, D, F. Okay, here see first shell, it has only one subshell. It has only one subshell. This is S orbital or S subshell will give maximum 2 electrons. Okay, maximum 2 electrons only. It will next see 2. Okay, second subshell which have 2 subshells S and P. S and P, that means total how many orbitals are there? 3 orbitals are there. Here its value will be 3. That means it will maximum give the capacity to 6 electrons. Maximum give the 6 electrons. Next D, it has 5 subshells. Okay, it has 5 orbitals. D subshell has 5 orbitals. It will give 10 electrons. Okay, each orbital give the 2 electrons accommodation. It has 5 d orbitals, so 5 to the 10. F has 7 orbitals. It will give the accommodation 14 electrons. Okay, by using this formula we can find out the ML, okay, or magnetic quantum numbers values. Okay, next fourth one. Okay, fourth one or last one, that is spin quantum number. What we learn till now means quantum numbers are classified into 4 types. That last one, fourth one is spin quantum number. Spin quantum number. Spin quantum number. Here spin quantum number is denoted with MS. Spin quantum number denoted with small s in small m and subscript s value. Okay, this was proposed by Gaudsmith and Uhlenbeck Samuel. Uhlenbeck Samuel was both are proposed this in quantum number. Here it is every orbital gives the accommodation to only 2 electrons. Here when in an orbital, imagine this is an orbital, it will give maximum only 2 electrons accommodation. In this orbital, this when 2 electrons are present, it will be must be opposite in their direction. Opposite in their direction. That means it will be when electron is revolving around the nucleus, it means in a clockwise direction. Means its value will be taken as positive. When an electron is revolving around the nucleus in a anti-clockwise direction, means its value will be taken as negative. Okay, so this is the spin quantum number. It is denoted with small m subscript s, ms. It was proposed by Gaudsmith and Uhlenbeck Samuel. Here according to this quantum number, every orbital will give accommodation to the only 2 electrons. When 2 electrons are present in an atom, it must be opposite in their direction. For example, when electrons are revolving around the nucleus in clockwise direction, it will be, its value will be taken as positive. When electrons are revolving around the nucleus in opposite direction or anti-clockwise direction, its value will be taken as negative. By using for these quantum numbers, we can find out where the electrons are present in an atom. Here next shapes of the orbital. Shapes of the orbital. Here s, p, d, f, 4 orbitals are there. That is s orbital, p orbital, d orbital and f orbital. It is s orbital and p orbital and f orbital. S orbital is in the shape of sphere. It is in the shape of sphere shape. That means think but okay like this. S orbital is in the shape of sphere. P orbital is dumbbell shape. Okay, p orbital is dumbbell shape. That is like this. Okay, this is the dumbbell shape. Here d orbital is in the shape of double dumbbell. Double dumbbell. That means here this is the f orbital is in double dumbbell. F orbital is four-fold dumbbell. Four-fold dumbbell shape has